Hello, everyone. Welcome to SUSECON Digital 2023. The topic of this session is Kubernetes onboarding from developer's perspective. Before we begin, a few words about who am I. My name is Krzysztof Poremski. I am a software engineer with over 8 years of professional experience. For the past 4 years, I've been lucky to work at StoneX, where I'm currently a technical leader in the retail department. My main job is to build and modernize our trading platform. I really enjoy programming. I even like to do this after hours. So I spend a lot of my free time working on different open source projects. To give you a glimpse, I am a committer and project management committee member for the Apache ActiveMQ project. Recently, I also got the chance to join the Cloud Native Foundation, where I contribute to the Open Telemetry project. Besides that, I have a technical blog, havred.io, where I write about messaging and the challenges of building distributed systems. Lastly, I'm happy to tell you that by the time you are watching this talk, I will be a proud father to a lovely baby girl. She is the wonderful reason why I wasn't able to attend this year's SUSECON in person. Okay, let's move to our presentation. From what you can gather, it's clear that I'm not a DevOps. I'm not a Rancher expert, and by no means I'm a Kubernetes expert either. I know, that's a shame if you consider that this is a presentation made for SUSECON Digital, but I'm just a simple software engineer. Nevertheless, in this talk, I would like to share with you what changed in our organization since we adopted Rancher. And by Rancher, I obviously mean Kubernetes, because from a simple software engineer's point of view, this is what Rancher is: a piece of technology that allows you to painlessly introduce Kubernetes to your organization. You cannot really begin to appreciate your life with Kubernetes until you compare your life with and without it. When I joined StoneX, or Gain Capital as the company was called before the acquisition, we haven't been using Kubernetes. Even though I thought, and I still think, that our CI CD pipelines were pretty decent. All of our services were hosted on Windows virtual machines. Most of our source code was kept in Git repositories, with a handful of embarrassing exceptions. Some really old projects lived in TFS, and I believe they still do. But in general, it wasn't that bad. We were using TeamCity as our build tool, and Nollier was our deployment and release management tool. Our CI/CD pipelines looked more or less as follows. When an engineer implemented a new feature or fixed a bug, he or she had to submit a pull request, so the proposed changes could be reviewed and looked over by other fellow engineers. Each PR automatically triggered a job in TeamCity that built the given service and executed the test suite against the proposed changes. With all the tests passing and code review finished, the PR was ready to be merged to the dev branch. After that, another job on TeamCity kicked in and executed the whole build process again, this time with the build artifacts as the final output. These build artifacts in the form of binaries and accompanying them configuration files could then be picked up by one of our QA engineers and deployed to the pre-production environment using Nolio. At this point, the quality assurance phase started. Having the green light from our QA buddies, we could safely merge back our dev branch to master. Another TeamCity build, and at some point, we could schedule the release to production. As you may remember, I described these CI/CD pipelines as pretty decent. I was very specific about it because pretty decent by no means mean perfect. They work, and we didn't know any better, but you can easily pinpoint some issues in the description I've just provided you with. For starters, our deployments weren't repeatable. What does it mean to have a repeatable deployment? It means that what you are deploying to production should be as close as possible to what you have deployed and verified on non production environments. In our case, it clearly doesn't seem to be close enough. We've separate branches for pre production and live environments. We were deploying slightly different flavors of our software depending on target environment. That's a problem, as it allows some subtle bugs and issues to slip by unnoticed. We traded this for an illusion of control of what actually gets into production. The problem that dev branches were meant to solve, instability of the product, is a legitimate one, but one that could be far better solved with more extensive use of tests, continuous integration, and quality enforcement practices like thorough code review, most of which we have already been using. What was missing was the right tooling to actually connect the dots. With the adoption of Kubernetes, we decided to abandon the dev branches altogether, and we have never looked back. Our new and shiny pipelines look as follows. Of course, it all starts with an engineer submitting a pull request. This triggers a job in TeamCity that's building our application and executes unit test suite against the change. Then it builds a Docker image with the application and actually deploys it to the Kubernetes build cluster using Helm. After that, another suite of tests is executed against our application. These are component tests. When everything is green and PR is approved, we can merge it to master. The first part of the master branch flow is exactly the same as in our pull request flow. This time, though, it doesn't end with component tests. As a next step, the deployment to pre-production is triggered using Octopus deploy. After successful deployment to pre-production environment, a suite of end-to-end tests is triggered so we can be sure that our service works fine with the others. Before we can promote our release to production, we need to wait for the green light from our QA engineers. Having that, we can start the final release process. Each release to production requires two or more approvals depending on potential risk qualification. The first approval is given by your fellow engineer and the other by the domain owner. For higher risk deployments, the additional sign-off from the change advisory board is required. With all the boxes ticked, you can promote your release to production with a single click in Octopus. The beauty of this approach is that the same artifact, the same application that we ran our tests against, is actually deployed to pre-production and then to production environments. This leaves a very small margin for an error. Finally, we have a truly repeatable deployment process. On the previous slide, I briefly touched upon component tests in the context of our new CI/CD pipeline. Indeed, these tests are pivotal to our IT modernization efforts at StoneX Retail, especially from a software engineer standpoint. When you ask an experienced engineer why they write tests for their software, the most common answer is that it gives them peace of mind. A well-constructed set of tests gives them confidence because it assures them that their software will work as expected. It also makes it easier to make changes without causing any problems. Writing quality tests can be quite a challenge. Let's say that you've got the project solidly covered with traditional unit tests, hitting 90% coverage or even higher. But every now and then your deployment trips and fails. Sounds familiar, doesn't it? We've been there too. Several reasons could be potentially behind this. For example, every application has some initial startup code, typically the main method. Does your test suite execute this method? If not, how can you be sure it won't stumble and fail after deployment? Our applications typically don't operate in isolation. They integrate with external components, which could be other applications, databases, or message brokers. A go to approach for unit test aficionado is to isolate these components using mocking frameworks. Mocks are designed to replace real dependencies with the APIs that we, as test authors, can control. This approach simplifies test writing significantly. However, it comes with a downside. We no longer use the real protocol, be it REST over HTTP, AMQP, or gRPC. For mocks, the specifics of the protocol are irrelevant, as the actual call never leaves the safety of the process where our unit tests run. So, how can we be confident that our application won't malfunction when deployed to a production or pre production environment? The truth is, we can't. This principle also applies to database queries. It's hard to count the number of times during my career that I've seen database queries that were deemed too simple to test, only to spectacularly fail right after deployment. As you can see, these scenarios all point to a common problem: the lack of proper integration testing. Yes, writing this kind of test can be challenging, but does it really have to be? As it happens, Kubernetes effectively addresses one of the most significant challenges of integration testing: setting up the dependencies together. With Kubernetes on our side, we've found a way to write integration tests, or component tests as we prefer to call them in our organization, that are not only easy to write, but also easy to maintain and execute. In our context, a component test is a test executed against a piece of software solely through its public API. The assertions that we can make are limited to the side effects produced by the system under test. These side effects could be responses to our calls or events published on a message queue. The application is permitted to communicate with its dependencies using only the protocols it would typically use in a production environment. This means we are not creating any artificial conditions using reflection based mocking frameworks. This doesn't imply that we need to set up our entire platform for the sake of testing. That approach doesn't scale well. When it's practical, we use real dependencies. For instance, we use actual version of SQL Server or MongoDB, and we also use a real message broker. It makes sense to use these real dependencies because their nuances shape and define our implementation. It matters whether the message was sent to the right queue or if the dataset returned from the database aligns with our expectations. For simpler dependencies, like the external HTTP based services, it's sufficient to use stubs, like WireMock. In case of HTTP based dependencies, the contract is what is critical. It is essential to know whether the downstream service can understand our request and if we can deserialize the response we receive. Stubbing with strongly tapped WireMock gives us exactly that. Kubernetes has empowered us to bring this idea to life. We can easily deploy and configure everything we need to run these types of tests in our Kubernetes build cluster. If you want to know the details regarding our implementation, there is a great presentation given by my friend and colleague Cesare during our small StoneX SUSE meetup in Krakow. I will try to include a link to it in the comment section for this video. Another huge win that Rancher and Kubernetes brought to our organization is in terms of infrastructure provisioning. Back in before the Kubernetes days, when you wanted to build a completely new service, you had to actually arrange all the necessary infrastructure. If there were some spare resources available, then half the trouble. The infra team could set up some VMs for you. If not, then you had to request some physical boxes. And this could take some time. Days if you were lucky, weeks or even months with the disturbed supply chains. Remember COVID? It wasn't that uncommon to have multiple services running alongside on the same VMs without any isolation. Obviously, setting up VMs was not the final step in our journey. With the VMs up and ready, you had to ask the ops team to install all the dependencies that your service might need, like the specific version of .NET or some native libraries that were required by your application. If your service were to be exposed via HTTP or other network protocol, some DNS configuration would come in handy, so you didn't have to know its IP address by heart to talk with it. The networking team would also need to configure the load balancer for you. It all took time and prevented us from moving fast and reacting quickly to business challenges. With Rancher and Kubernetes, it all seems like a bad dream. You want to start to work on a new service? All you need to do is to define a Helm chart that describes it. How many CPU cycles is it going to use? How much memory does it need? How many replicas do you want? On what URL should it be available? With a dozen of lines of YAML and a few clicks, you can have your service on pre-production. Few clicks more and a bit of red tape and it's live. It doesn't do anything yet, but it's there. All the dependencies can be included declaratively in your Docker image. So they are shipped with your application. If it works in the test phase, you can be fairly certain it will work in production as well. No surprises. Deploying your service to production is one thing. Maintaining it at scale is totally different story. With Kubernetes, you don't care on what physical node your service is deployed. You don't have to monitor if it's alive or not. If it breaks or hangs for whatever reason, runs out of the disk space, or the process just crashes, Kubernetes will bring it back to maintain the declared number of replicas. You got zero downtime deployments with rolling updates for free, so no more weekend patching. You can ship your service a dozen of times a day, and your users don't even notice it. Sudden bursts of traffic? You can easily scale your service out with the additional replicas. It's that easy. I love Rancher and Kubernetes because they take all these infrastructure shenanigans from my back and let me focus on what I really like to do, which is writing code, designing new systems, and solving technical problems. It makes my life and my everyday work so much easier. What I have presented to you during this short talk is just a tiny fraction of the features that these technologies can offer. There is so much more to it. Thank you very much for listening and have a wonderful day.